This is WAEC June 2020 General Mathematics Paper 2, and we are answering question number 11A, and the question reads, in the diagram, MNPQ is a cycle center O. So MNPQ, the name of the cycle, is a cycle that has a center at this very point called O. The distance MN is equals to the distance NP, that is the length of line MN. Is the something as the length of line NP, and you can even see the marks there indicating that these two sides are equal in length. Angle OMN is equals to 50 degrees. Is also marked in the drawing. Angle OMN, this is 50. The question asks is to find Roman 1 the size of the angle MNP. MNP, this very angle at N. And the Roman 2 you asked to find the size of the angle POQ. POQ, this very angle. So let's attempt to answer this very question to get a solution to the problem. Usually the angles asked to find, you may not get to those angles direct. You have to have, or you have to find some other angles that will lead you to get to those angles that the question exactly asked you to find. So if I should attempt to get the size of angle MNP, MNP, this very angle, now look at the information given in the question. I only have one angle at M, and we have also the length of MN and the length of NP to be equal. This is the only information that you can see from this question. So to find this angle, it's like you have to have some other angles. So let me just attempt to get the angle NPQ. NPQ, this very angle, look at it. Look at this very angle. This very angle, I can see that is opposite to this given angle, 50 degrees. And looking at MNPQ, MNPQ is a cyclic quadrilateral, and I have a theorem which says opposite angles of a cyclic quadrilateral are supplementary, which means I can now find NPQ. So NPQ will now be equals to 180 minus 50, and my simple reason, those two angles are opposite angles of a cyclic quadrilateral. Subtracting 50 degrees from 180 will give answer 130 degrees. So this angle is now 130. Let me mark it. I'll continue. My target is to get this angle at N. Let me see, I can find also angle MPQ. MPQ. This MQ is a diameter because it passes through the center. And this angle MPQ will now be angle in a semicircle. It will now be 90. So MPQ will now be 90, and the reason is it is angle in a semicircle. So if I have this NPQ as 130 and I have MPQ as 90, I can equally get NPM. NPM. So NPM is now going to be the whole of this, which is 130, minus this angle, which is 90. So I'm going to subtract 90 from 130. If the subtraction is done correctly, you have 40 degrees. So this angle NPM is now going to be 40 degrees. I'll continue. Still my target is to get the angle at the end. So look at a triangle MNP. MNP, the triangle is an isosceles triangle because two of its sides are equal. And this angle that I have just obtained, that is angle NPM, is a base angle, and it will not be the same thing with this other base angle. So I can now use sum of angle in this isosceles triangle to find the angle at N. So angle MNP, the one asked to find a Roman 1, will now be equals to 180, the sum of angle in a triangle, minus the two base angles, 40 degrees each. And my simple reason, it is sum of angles in isosceles triangle. Subtracting this 240 from 180 will leave you with 100 degrees, and that will now be the size of angle MNP. Let me mark it. So you're going to have 100 degrees. That answered the Roman 1 question. Moving to Roman 2, that asks to find the size of angle POQ. This is the angle subtended by arc PQ at the center of the cycle. So let me just think which other angles do I have to find so that it will lead me to get this very angle. If you look at your drawing, the angle NMO is 50 degrees given in the question. And I have this angle NMP as 40 degrees as base angle of this isosceles triangle. I can find this very small angle, that is angle PMO. Angle PMO. This very small angle, I can find it by simply subtracting 40, this base angle, from the whole of that angle 150. So subtracting 40 from 50 correctly gives answer 10. So this very small angle will now be 10 degrees. That is angle PMO. And looking at arc PQ, is the one that subtained angle POQ at the center of the cycle, and is the one that subtained angle PMO at the remaining circumference. And the theorem says angle at the center twice angle at the remaining circumference, which means my angle POQ asked to find in Roman 2 would now be equals to 2 multiplied by 10. 10 is the angle at the remaining circumference, while angle POQ will now be the angle at the center, subtended by that arc PQ. So multiplying 2 by 10 correctly gives answer 20, which means the angle POQ is now going to be 20 degrees. And that answered all the two questions. Let me just share with you quickly the mark distribution for this very question as it is there in the marking scheme. So the very first mark is bonus 1 mark. And that bonus 1 mark is for getting 130 degrees as the size of angle NPQ. You have that bonus 1 mark. Next mark is another bonus 1 mark for getting angle MPQ as 90 degrees. Next mark is another bonus 1 mark for getting angle NPM as 40 degrees. Next mark is method 1 mark for attempting to get the angle MNP, subtracting the two base angles from 180 using this theorem sum of angle in isosceles triangle. That will enable you to get this method 1 mark. Next mark is accuracy mark, when you now have 100 degrees exactly as the size of angle MNP. Next mark is accuracy 1 mark for getting angle PMO as 10 degrees. You have this accuracy 1 mark. And the next mark is method mark for attempting to get the angle POQ using the theorem angle at the center twice angle at the remaining circumference. You have this method 1 mark. And when you now have the angle POQ exactly equals to 20 degrees, you have this accuracy 1 mark. So if everything is done correctly in this very question, you now have 8 good marks.